Let's go to the next part, next question, which is what are the different techniques in Python for running a Linux command? So far, if you guys have attended my previous session for shell scripting, what we have seen is that shell scripting is nothing, but we are putting a bunch of commands in a script, and then we are adding some kind of a blocks, for example, the conditional blocks, or we are adding some kind of a loop and everything to make our script work. Okay, so as a DevOps engineer, you should know how to execute all of these commands. So for example, if you are transitioning from your script from shell to Python, or you are writing your script in Python and you want to execute some of the Linux command, how to do that? Okay, so anyone know how to execute a Linux command using Python? So let's not go to some of the in-depth command. Let's say in my Python script, I want to execute the ls command. Anyone know how to execute this ls command in Python? Yes, sub-process module. Exactly, David. Okay. But before going to a sub-process module is a recommended way, the way that we have seen that OS is a general purpose module, but sub-process module is specifically designed to run all these Linux commands. Okay. I will just show you if we can how to do it with the OS command, OS module, and then we will jump to the sub-process. Okay. So in case of a OS command, there is something called os.system. That's why I told you OS is really, really important. And if you do ls, okay, we are using one of the system thing, and through which we are trying to execute this ls command. And if you see, whatever the files present in this particular path where we are in, we are able to execute the command. And OS also provides something called get cwd, which is similar to we have pwd, right? Print working directory. So we are in this home p-lakaya directory, and inside it, whatever the files we have, we are able to execute it with the help of a ls. We are able to execute it with this os.system. Okay. Now, there's a really one big limitations of this os.system. Anyone know what is that limitation? So I execute, like the David said that we should start using the sub-process module to execute a command. But you will see that we have this pretty simple, straightforward command os.system, right? And using this OS system, we are able to execute the command. But why shouldn't we use this os.system? Okay, just in the interest of time. So let's say I use a variable called RT to store the output of this os.system ls command. I mean, I'm executing the ls command using OS system, and I want to store this output. I don't want this output to be on the screen, right? I want this output to be saved in this particular variable. You can take any variable, it's fine. Okay. Now, still you have seen that you have seen this output, and one thing which is missing over here is this 0. And if you print this variable now, you see that it stores the RT, which is the return code. So that is one of the big limitation of this os.system. It does not have the capability to store the output. Okay, it only stores the return code. So you can see it over here. If I use some of the any bogus command, okay, and if I try to print it, it stores the return code that the command which I'm trying to execute does not exist. Okay, so that's the major limitation of this os.system, and that's why the sub-process modules comes into picture, which stores the return, not the return code, but the output of that executed command. Okay, but before going to os.system, I found something really interesting through which you can perform the same activity. So OS itself provides something called popen. Open, and if I execute this command, and basically after executing this command, okay, I need to specify something called read. And if I say here, let's say output. Now you see it does not display the output to my screen. I can simply say output. So now the output of the command that I have executed stored in some variable, right? And that variable, I can use it to perform a particular activity. So for example, if I want to see like what is the size of all the file inside the directory, I can do that. Or if I'm looking for some specific file, for example, let's say hello.sh, I can perform some activity. But using os.system, I can't do that. I mean, I can do that, but I cannot use it for further processing. Okay. So that's why using this popen and read method, I can store the output of this using the os command of any command using this popen method. Okay, is clear? Now let's look at the big one, which David has mentioned, which is called subprocess command. And this subprocess command is a recommended way to execute, I mean, to uh, to get the output of any of the command. Okay, and I mean, this is basically a replacement of bunch of OS commands. So if you go through their documentation, they will say that this command is going to replace. Let me paste you this one. So basically, the subprocess module is going to replace all these modules and function, os.system, os.swapen, os.popen, which we have just seen. So that's the use of subprocess command. And basically, it provides a lot of functionality. So we will see some of these functionality, but how to use it? Let's see that. So basically, in order to use any of the module, we first need to import it, right? And then let's say output equal to subprocess dot run. Okay, ls. I will tell you what exactly I'm doing. And let's say this time I'm executing ls-l. Okay, let's close this one. And std out is equal to subprocess dot py. Did I do wrong? Subprocess is equal to this. Oh, std out, sorry, not start out. Put dot std out, print this one, and you see we get the output of this ls-l command. Okay, so what exactly I'm doing? Okay, so basically, if you look at, okay, let me copy this one and then I will show you what exactly I'm doing it over here. So basically, if you want to use any of the modules in case of Python, you first need to import it. And then I have used something called subprocess.run. So let's try to break this one. Okay, this one. So subprocess.run is, like I mentioned, subprocess is one of the recommended way how you are going to execute your Linux command in case of Python. And run function is one of the recommended approach. Okay, so basically, if you see this run as a method, it handles a lot of complexity. So for example, executing this command and getting the output back of this command, all these under the hood thing is being handled by this run method. Okay, and now we are passing a string to it. Okay, and the thing is, okay, if you go to Python console, okay, and if I say cmd is equal to ls-l dot split, this one. So basically, I'm passing a string in the form of a list to this command. Okay, and this is the way that your subprocess.run accepts the argument. Okay, so I mean, if you know about the earlier sub-process module, we have something called shell equal to true or shell equal to false, right? And this is one of the way that people can inject vulnerability to your shell. Like while passing the command, they can pass some of the argument which may impact your shell or which can cause vulnerability. So that's why this is one of the way where we are passing so that you cannot pass any of the unwanted argument to the shell. And shell always accept your argument in the form of this. Okay. So we are whatever the command you need to pass in the form of the string. Okay. And last thing is that we need to get the output, right? So I showed you that OS of system has one limitation that we cannot capture the output of the running command. And that is why we have this standard output equal to subprocess.pipe, which is capturing your standard output of the command. Okay. And this is what allows you to access the command from the from the variable from where we have captured. So in the shell session, I showed you something called standard in, standard out, and standard error, right? So basically, we are capturing this output from standard out, which is our terminal. And we are capturing this output. And once we capture that output, we are just displaying it on the screen. Okay. One thing, if you notice here, that I'm getting something called this B, right, at the start of this output. And this is called a bytecode. Okay. Anyone know how to convert this bytecode into a string? Okay. So, I mean, when the shell, okay, or let me put it this way. So when you are printing this output to a screen, okay, I mean, either it's a standard output or standard error, it produced in terms of something called bytes. Okay. And these bytes are representing whatever the text you are displaying on the screen, right? But Python has no idea how to decode this byte into a string. So if you want the output to be in the proper format, you just need to use something called decode. And now you will see that your output is in the proper format. Earlier, we used to do something called read lines to read the text and all those things. But I think this is a much cleaner way through which you can get the output back to your screen. Okay. So three ways we can, I mean, this is a really important question from the interview point of view or for your day-to-day activity, that how to execute any of the Linux command. Like, I mean, I gave you an example of this ls-l, but let me show you, for example, any of the command. If you want to execute, you can execute it with the help of this os.system or subprocess.run. Anything is so same command, you can execute it over here also. P-m, let's say. Any Linux command, if you want to execute, you can do it either using os.system. I showed you os.popen, and the recommended way to run this command is called subprocess.run. Okay. Any questions so far? Whatever we have discussed. We started with the OS, then we now switch to the subprocess. Any questions in between OS versus this subprocess module?
Can you elaborate a bit more when you talk about the subprocess.run and the vulnerability it impose there is?
Okay, so let me. So, I mean, in the earlier days, I need to go back to some time back. Uh, there is a functionality called shell equal to true and shell equal to false. Okay, so shell equal to true means if you're executing any commands in your shell, and shell means your prompt, right? And those commands will depend upon any of the environment variable. And we have seen the environment variable like this, right? These are all the variables which has been loaded, right? And these loaded variables are the ones you want to call in your script. So let's say your script need, you guys all know, like if I want to find it out what is the default shell or in my system, I need to use echo dollar shell, right? And using this sub process module, I want to execute this command called echo dollar shell, right? Now, the problem is that anyone who hacked my system, they might inject some kind of a vulnerability in my shell. And using those vulnerability, he want to execute a command. Okay. So that's why they said that rather than doing like this, it's always a good idea to break a command like the way so that people will not inject any kind of a like a misleading kind of a string or something like that to your command. I know David is kind of confusing and I think I have confused you, but I will share some doc with you if you can ping me on LinkedIn that how to mitigate these kind of a vulnerability. But for this basic session, I can tell you like the standard way to pass any of the command to your subprocess.run is to in the form of a list and break it into this string. And if you don't know how to do that, I mean, the way you can do it is like ls-l and dot split it. So for example, if I want to run the other command like p-m, it breaks it into two part for me.
Thank you. So the I guess the concept is if we don't want to have vulnerability by referring to commands stored in the shell or the environment variable, then we just kind of like hard code it, the actual command the way you have done it right now.
Yes, exactly.
I see. Thank you.